We'll see the average code word length. Okay, average code word length, or otherwise first coding. When we come to the coding, here we are discussing source coding only, not channel coding, source coding. In general, source coding is of two types. Okay, that coding may have uniform coding. The coding can be uniform and then non-uniform. Coding can be uniform and then non-uniform, or otherwise non-uniform. Uniform coding means irrespective of the probability of the symbol, we will assign always equal number of bits. Say for example, in simplicity, I am having four symbols, S1, S2, S3, S4. Then I can encode the symbol 1 like 00, 01, 10, 11. I can encode like this. Only in my system, only there are four symbols. I can encode that symbol in this manner. Again, here there is no confusion. At the receiver side also, I will combine two symbols at a time. Okay, when I am observing 01 at the receiver, then I know that is indicating the symbol 2. This is the concept of uniform coding. This is the concept of uniform coding. But whereas in non-uniform coding, what we will do, say this is S1, S2, S3, S4, there are four symbols. Definitely each symbol will have its own probability. Here, in case of uniform coding, we are not worried about the probability, just because uniform, irrespective of the probability, directly we are assigning equal bits, equal length of bits. Okay, equal length of bits. So once, if it is in case of non-uniform coding, in case of non-uniform coding, say for example, for symbol 1, we are assigning 0. For symbol 2, it is 10, then 110, then 111. So here also, I am assigning bits, but for symbol 1, I am assigning only 1 bit. For symbol 2, I am using 2 bits. For symbol 3, 3 bits. Symbol 4, 3 bits. So now, why do we go for non-uniform coding? That is very important here. Why we go for non-uniform coding as compared to the uniform coding? So first of all, for that we should know what is the average length of the codes. Okay, yeah. In case of uniform coding, calculation of average length is very simple. That is 2 only, because we are having 8 symbols. At any point of time, each symbol will occupy 2 bits. Okay, average code word means what is the number of bits present in each symbol. So average code word is 2 only. But whereas in case of non-uniform coding, okay, I cannot find average directly. If you want to find out average, you should know the probability of the event. You should know the probability of the event. Say for example, symbol 1 is having 1/4 probability, and then symbol 2 is also 1/4, and then this is 1/8, this is 1/8. Okay, here it is having different probability based on some method. Okay, there are 2 methods based on some method, or any other based on other than the 2 method. Also, we can use any other method based on some method. I have assigned the codes. Okay, I have assigned the codes. Now, what is the average length here? What is the average length here? So we should know what is the formula for average length in case of non-uniform coding. Mostly we will concentrate on the non-uniform coding. So what is the average length in case of non-uniform coding? Say the average length in case of non-uniform coding, L bar average is equal to summation. What is the probability of the particular event? What is the probability of the particular event? What is the number of bits? What is the length of number of bits assigned to that event? Okay, that is Li. Okay, so Pi means probability of the event. How many number of bits you have assigned? That is Li. So once if you calculate this, you will get the average code word length. So as I have already calculated, just I am putting, say it's simple, 1/4 into 1, 1/4 into 2, 1/8 into 3, 1/8 into 3. If you add everything, you will get the L average. Okay, so once if you do this, you will get 1.75 bits per symbol. 1.75 bits per symbol. Can anybody tell me what is the main observation with respect to these L averages? Okay, this L average is with respect to uniform. this L average is with respect to non-uniform. Can anybody tell me what is the observation here, which is having less average code word length? Uniform or non-uniform?
Non-uniform.
Yes, definitely non-uniform. So now we'll see what is the main objective of source coding. What is the main objective of source coding? See, you are given some message. You are given some message. You want to represent this message in terms of digital format. Okay, somebody is coming, he is representing in terms of 1 KB. Okay, using some method, say method 1. Again, other person is coming, he is representing the same message with 1 MB. Okay, with 1 MB of data. So definitely the representation technique of a person was one is efficient. Okay, same message is representing with less number of bits. Same message is representing with the less number of bits. So that means that's why that is the main objective of the source coding. How efficiently you can represent the information. That is the main objective of the source coding. How efficiently? What is the source coding? Source coding. Efficient represent of the efficient representation of messages. Efficient representation of messages. Efficient representation in the digital domain in terms of bits. Efficient representation of messages. That means with less number of data. How efficiently you can represent the given message with less amount of digital data. That is the main objective of the source coding. That is the main objective of the source coding. Okay, that means what actually we are doing here. So you see, one person is representing with 1 MB, another one is with 1 KB. So there is some redundant information here. He is removing that redundancy somehow. Okay, so source coding, another idea is removal of the redundancy. Removal of the redundancy. Another term for defining the source coding is removal of redundancy present in the message. Removal of redundancy in the message. Removal of redundancy in the message. That is the main objective of the source coding. So, in this observation, we have concluded that definitely L average. Okay, whenever I put bar, that is representing average. Once again, I no need to write average here. The average code word length for non-uniform coding. Non-uniform coding, definitely it will be less than or equal to average code word length of uniform coding. This is the first observation. Okay, average code word length of non-uniform coding is always less than or equal to average code word of the uniform coding. That's why we always go for non-uniform coding. That's why we always go for non-uniform coding. And again, one more cap is there here. At any point of see, now we have concluded definitely we'll be using non-uniform coding. So now what is the observation? Non-uniform coding is the best. Non-uniform coding is the best. So hereafter, whenever I use L bar, that is automatically indicating the non-uniform coding. Okay, so now, but again, this average code word length of non-uniform coding cannot be less than the entropy. Cannot be less than the entropy. See, for a given system, there will be some entropy. Okay, so this average code word length cannot be lesser than the entropy. Again, you have to be very clear here. What is the main difference between entropy calculation? In the entropy, along with the probability, we will be multiplying log of 1 by p. But in case of average code word length, along with the probability, we will be multiplying number of bits. So there is difference between these two. So now what I am telling, at any point of time, as per, with the help of some practical method, we will be finding the average code word length of non-uniform coding that cannot be less than the entropy. That means what I am telling, it will be always greater than or is equal to entropy. But what is our aim? There are two different methods. Okay, so mostly we have to try to make L average to go close to H. we have to try to bring L average as close to H. See, in case of uniform coding, it was much larger. By using non-uniform coding, we have reduced the average code word length. What is our ultimate aim? What is our ultimate aim? Our ultimate aim is, by using any method, we have to try to bring this L average to go towards H, but it cannot be less than H. We can go towards H. We may also reach H, but at any point of time, L average cannot be less than H. That is the important observation. So for any given scheme, now we have to define the efficiency. Any given scheme, you know, efficiency is always less than the 100%. Then what is the efficiency? H divided by L average multiplied by 100 is the formula for the efficiency of the code. Efficiency eta is equal to H divided by L average. Okay, so if you want to get 100% efficiency, the only way is, in general, L bar is greater than H, but you try to reduce L bar close to H, then you can get 100%. Okay, that is the main aim of any coding scheme. So each and every coding scheme may have different efficiency. The one which is having higher efficiency is the better coding. Okay, the one which is having value very close to H, that coding, we'll call it as a most efficient coding. So again, here itself, we can conclude what is the most efficient coding possible. That is the entropy. Entropy is the most efficient one, but practically we cannot use. That is the formula. Okay, entropy is the formula. If somebody asks, in general, theoretically, or sorry, mathematically, what is the most efficient coder? That is the entropy coder. But practically, it is not existing. So, basics எல்லாம் வந்து பார்த்துட்டோம். Entropy, average code word length எல்லாமே வந்து பார்த்துட்டோம். Now we will take some problems for this. So source coding. In source coding, we are having two varieties, two practical source coding method. One is Shannon-Fano coding, and then another one is Huffman coding. That means same problem, you can solve it by any method, Shannon-Fano or Huffman coding. In most of the cases, both the method will be giving same result. That means same average code word length. Our ultimate aim in coding is to bring the average code word length towards H bar. That means entropy towards H. Mostly both the technique will provide same answer. Say, now I am defining L bar with respect to Shannon-Fano, then L bar with respect to Huffman coding. Okay, these are all two independent practical source coding scheme. So at any point of time, mostly they may be equal, but for some problems, the Huffman coding may provide efficient result. That means L bar as low as possible. In most of the cases, both the technique will provide the same result, but in some cases, there is a possibility Huffman coding may perform better as compared to the Shannon-Fano coding. It all depends on how that probability is distributed inside the symbols. Okay, so that's why we conclude Huffman coding is the most efficient coding. Due to this, Huffman coding is the most efficient coding, most efficient source coding. Huffman coding is the most efficient source coding. Huffman coding is the most efficient source coding. So now I can compare everything. See, I have defined many parameters. Finally, I am writing it in a single slide. Okay, we started with L bar uniform coding. Then we have defined non-uniform coding. In non-uniform itself, we are having two things. One is Shannon-Fano and another one is Huffman coding. Then this is L bar Shannon-Fano. then this is L bar Huffman coding. Again, finally I will get H. Finally I will get H. Now, this is the overall idea of this topic. Actually, what will be happening in future, just I am summarizing in the single slide. Uniform coding. In non-uniform coding, there are two methods. In that, Huffman will perform better. But out of all these, theoretically best encoder is the entropy encoder. But practically, we cannot use entropy encoder. That is the theoretical definition. Again, mostly to be on safer side, we always will put equal sign also. So this is the final conclusion. So now I can take the regular problem. So now first we'll see the Shannon